Good evening students. Today we are going to see what is multiplexer and how we are going to practically implement it. Multiplexer or data selector is a combination circuit that accepts several data inputs and allows only one of the input to the output at a time. The routing of the desired data input to the output is controlled by the number of select lines. For example, if you are having 2 power n is to 1 max, we should have 2 power n number of data lines and n number of select lines for this multiplexer. So now we are going to see how a 2:1 multiplexer is implemented. This is the block diagram of 2:1 multiplexer. Since it is a 2:1 multiplexer, there are two number of inputs here and only one output here. So D0 and D1 are the actual data inputs. So what is the function of the data multiplexer? Only one of the input is selected and that value is passed to the output. So to determine which input to be selected and passed to the output is based on the select line. Since we are having only two data inputs, we need only one select line. So when S is 0, the data available on D0 is made available at output, and when S is 1, D1 is passed to output AZ. So this is the functional diagram of your 2:1 multiplexer. So when S is equal to 0, the output is D0, and when S is equal to 1, the output is D1. So from this we can derive the Boolean expression for this, which is Z is equal to D0 into S bar plus D1 into S. You see here S is equal to 0 and the output is D0. So 0 is taken as S bar and it should be multiplied with D0, that is the mean term for this. And similarly here S is equal to 1 and this is D1, so this is D1 plus S. Using this Boolean expression, we can implement 2:1 multiplexer as like this. Here we are having two AND gate and one OR gate. Here D0 is connected to first input of the AND gate and D1 is connected to the second AND gate, and select input is directly connected to one of the AND gates and inverted and connected to the another AND gate, and the outputs of the two AND gates are connected to OR gate, and finally the output of multiplexer is taken from the output of OR gate. Now we are going to see how this 2:1 multiplexer is practically implemented. This is OR gate and this is our AND gate and this is NOT gate. So as per the circuit diagram we discussed previously, we made the connections, and you see these are the two data input lines and this is a select line. Now the select line is 0 and D0 is 0, so the output is 0. If you made D0 as 1, then the output is 1. Similarly, when the select line is made as 1 and D1 is equal to 0, the output is 0, and if you made D1 is equal to 1, then the output is 1. So in this way we can implement a 2:1 multiplexer practically, and the function table of this multiplexer is verified. Thank you.